Okay, so hello everyone. So today's topic is magnetism, and in this topic we will solve all the numericals given in the state board textbook. In state board textbook total there are 5 numericals. So let us begin with question number 1. So have a look at question number 1. Magnetic pole of bar magnet with pole strength 100 ampere meter is 20 centimeters away from the center of a bar magnet. So there is a bar magnet, and the bar magnet ka this is center. Magnetic pole of bar magnet with pole strength 100 ampere meter is 20 centimeters away from center of a bar magnet. Now this is a bar magnet. Is say 20 centimeters away there is a pole. So the bar magnet of pole strength is bar magnet ka pole strength. What is meaning of pole strength? The strength of north and strength of south pole. Now we know that in bar magnet the strength of north pole is given as positive. It is always considered positive. So plus 200 है उसका strength, and the south pole का strength is minus 200. And the length of the magnet, is the magnetic length, is 5 centimeters. This is a short magnet. If the pole that is given in the question, which is 100 ampere meter, if the magnetic pole is on the axis of the bar magnet, on this is bar magnet और इस bar magnet के axis पे, this is called as the axis. On the axis of the bar magnet, the pole is present. Let us say this is that magnetic pole, 100 ampere meter. This magnetic pole is on the axis of this bar magnet at the distance of 20 centimeters. 20 centimeter distance पे the pole is present. What is the force acting on this pole? Now we know that force between magnetic pole and a magnet can be calculated by using the concept of magnetic induction. Magnetic induction का definition है, एक definition तो है Weber per meter square, that is flux passing through unit area, but the other definition is force acting per unit magnetic pole. Force acting per unit magnetic pole. So how to calculate force on this pole? Now since this is a positive pole, north pole is also positive pole, there will be repulsion. So what is the net force acting on that pole? The net force will be magnetic induction, यहाँ पे जितना magnetic induction है, into the pole strength. So for that we need to calculate what is magnetic induction at this point P. Let us say this is point P, which is the axial point. So magnetic induction on the axis of a bar magnet can be calculated as mu naught by 4 pi 2m over r cubed. This is the formula for short magnet. Now since the magnet is short, distance is only 5 centimeters and the distance on the axis is 20, which is large as compared to the length of the magnet. So we can treat this formula, we can use this formula for solving this numerical. Now we know the value of this constant mu naught by 4 pi is 10 to the power minus 7 into 2 into what is this m? Now this is called as magnetic dipole moment, which is the product of pole strength. Take any one pole plus or minus, we have to take the magnitude into the magnetic length. The length is 5 centimeters. So centimeter, centi is 10 raised to minus 2. On solving this, you will get 10 ampere meter square SI unit. So the value of m we have calculated is 10 divided by r, that is the distance, is 20 centimeters, which is 0.2 meter, and its cube will be, this is 2 into 10 raised to minus 1, so its cube will be 8 times 10 to the power minus 3. On solving this, the magnetic induction will be, ये है 10 raised to minus 3, minus 7 का minus 4 बचेगा, ये 10 raised to 1 है, 10 raised to minus 4 का 10 raised to minus 3 बचेगा, and then what is left is 2 by 8, that is 1 by 4, times 10 to the power minus 3, and if I adjust 10, that is 10 by 4, it will become 10 to the power minus 4. So the magnetic induction is 2.5 into 10 raised to minus 4 Tesla. So magnetic induction we have calculated at this point. कितना आया है? 2.5 into 10 raised to minus 4 Tesla into what is the pole placed over here. The strength of the magnetic pole is 100 SI units. So I need to multiply by 100. So 100 into 2.5 into 10 raised to minus 4 will give you 2.5 times 10 to the power minus 2. As it is force, the unit should be Newton. This is the answer for question number 1. Net force acting on this pole. This is the answer for question number 1. Okay, so let's have a look at question number 2. A magnet makes 45 degree with horizontal in a plane making 30 degree with magnetic meridian. Find the true value of angle of depth. So let us consider two planes first of all. This plane is geographical meridian, whereas it is making 30 degree with magnetic meridian. So magnetic meridian hai piche. This is magnetic meridian. And as we know that angle of dip is always measured in magnetic meridian, not in the geometrical meridian. Magnetic meridian में Earth's magnetic field will have two components. One will be BV, vertical component, and the other one is called as BH, which is called as horizontal component. But the problem is the magnet is lying, it is making 45 degree with horizontal in a plane 30 degree with magnetic meridian. Magnetic meridian से 30 degree plane पे there is another plane, and इस plane में the magnet is making 45 degree. So let us say magnet is making 45 degree, this is magnet. So BH का this component will be BH cos 30. This component will be BH cos 30. And this BH cos 30 and BV का resultant में this is making 45 degree. So the magnet is making 45 degree in this plane, general plane, right? Which is 30 degree with the magnetic plane. A magnetic meridian जो है उसमें BH and BV are present. लेकिन other plane में if you shift the plane, if you rotate the plane, तो plane rotate करने के बाद BV will remain same because it is still the intersection, but BH is going to shift कितने angle से? Theta 30 degree से. So this horizontal component will shift and it will become BH cos 30. So in this expression as angle is given, if I use tan 45 in the equation, tan 45 क्या मिलेगा? Tan 45 opposite side, that is BV upon what is the value of horizontal? BH cos 30. But since tan 45 is 1, I will get BH cos 30. This is equal to 1. BH cos 30 will be equal to BV. This is what we will get from this black color ka plane. Actual question is what is the true angle of dip? True angle of dip is the angle of dip in magnetic meridian. So magnetic meridian में the angle that the needle will make is angle of dip, and the actual definition of angle of dip is tan delta is equal to BV by BH. We need to just replace the value of BV. BV का value कितना आया है? BH cos 30 upon BH. BH will cancel. Cos 30 is root 3 by 2. If you put the value of root 3 by 2, you will get 0.866 as tan delta. So true angle of dip is tan inverse of 0.866. This is the true angle of dip. Angle of dip is tan inverse of 0.866. You can solve it to get the answer in degrees using log table, but this is the answer for true angle of dip. Okay, so the next question is question number 3. Two small and similar bar magnets have magnetic dipole moment 1 ampere meter square. They are kept perpendicular to each other and the distance between their centers is 2 meters. Find net magnetic induction at the center. See, two magnets are given. Two magnets are short magnets and they are kept perpendicular to each other. So let us say this is the first magnet and the second magnet. Short magnets hai. So I will draw the first magnet and the second magnet. They are kept perpendicular to each other such that their center to center ka distance is how much? Center to center ka distance is 2 meters. So this distance is 2 meters. Okay. So again I will draw the figure. First magnet, second magnet, both magnets should be similar. So first magnet and second magnet, and the distance between their centers, center to center distance, is 2 meters. And the question is, what is magnetic field at the center? मतलब यहाँ से 1 मीटर और यहाँ से 1 मीटर, यहाँ पे नेट मैग्नेटिक फील्ड क्या है? सो क्लियरली बिकॉज ऑफ दिस मैग्नेट, द मैग्नेटिक फील्ड ओवर हियर, suppose if this is north, this is south, the magnetic field, this is the equatorial point, right? For this magnet it is equatorial point, and equatorial point पे magnetic field lines north से start होके it goes in the left direction. So कैसे होगा magnetic field? Because of first magnet, ये first magnet है, इसका magnetic field will be B1 in this direction. और ये अगर north है और ये south है तो इसका इसके लिए for this magnet this is axial point, so the field will be north to south निकलेगा, so it will be in this direction B2. So B1, B2 are fields because of these two, and net field पूछा है, so vectorially we need to add them. So let us find B1 का value first. B1 will be equatorial point. So equator का formula क्या होता है? Magnetic field on the equator is mu naught by 4 pi m by r cube. If you substitute the values, mu naught by 4 pi is 10 to the power minus 7. Magnetic moment of each magnet is 1 by r is 1. So answer is 10 raised to minus 7 Tesla. This is magnetic field because of first magnet, that is this magnet, it is in left direction, right? What is magnetic field because of the second magnet? The magnetic field because of second magnet, let us say it is B2, will be mu naught upon 4 pi 2m by r cube. 2 now because this is axial point, axis का formula है 2m by r cube. So mu naught by 4 pi is 10 raised to minus 7 times 2 times magnetic dipole moment is given 1 by r. Again the distance for this magnet is also 1, so 1 cube is 1. So the answer comes out to be 2 into 10 raised to minus 7 Tesla. So these two fields if I show in diagram, then B2 is in this direction, B2, and B1 is in horizontal direction. So if the net field is asked, you need to simply use the net resultant formula of two fields, that is under root B1 squared plus B2 squared. And if you solve it now, B1 square 10 raised to minus 7 का square will be 10 raised to minus 14 plus B2 square will be 4 times 10 to the power minus 14, and 10 raised to minus 14 if I take common, तो रूट में क्या बचेगा? 1 plus 4 is 5 times 10 to the power minus 14, जिसका रूट आंसर है root 5 into 10 raised to minus 7 Tesla. This is the answer for question number 3. This is the net field. In which direction it will be? Approximately in this direction for this figure. Okay, so if you interchange poles, the direction is going to change, but the value will still remain same. Root 5 into 10 raised to minus 7. In decimal it will be roughly 2.25 times 10 to the power minus 7 Tesla, roughly. So this is the answer for question number 3.
Okay, so the next question is question number 4. The question is theoretical. So the question is, a circular magnet is made with its north pole at the center, separated from the surrounding circular south pole by an air gap. Draw the magnetic field lines in the gap. So the field lines will look in this way. North pole will be at the center and the lines will go from north to south radially outward through the air gap. The second part of this question was, draw a diagram to illustrate the magnetic field lines of force between the south pole of two such magnets. Now if two such magnets are placed, the lines should be shown pointing towards the south pole of each magnet. So this is the solution for question number 4. So the last question is question number 5. Two bar magnets are placed on a horizontal surface. Draw magnetic lines around them. Mark the position of any neutral point. Now what is neutral point? It is the point where the net magnetic field is 0 on your diagram. So in this question, how the magnets are placed is not mentioned, so we will discuss all the cases that are possible. Let us consider the first case where north of both the magnets are pointing towards each other. In that case, the neutral point will be at the center because both the fields will cancel out each other. In second and the third case, there won't be any neutral point as the magnetic positions are helping each other. But in the last case, the magnets are placed in such a way that the north are pointing in the same direction and south are pointing in the same direction. So there will be two neutral points as shown in the figure. So this is the solution for question number 5.